I have been on vacation. I have not had time to fix my computer to get my camera working again, so no me today. Today we're going to be working on Jackal and trying to figure out how to get the Jackal Maven plugin to easily support a version of Java higher than 8. Right now we are stuck at 8. We have this hard-coded in... where is it? Here we go. This is our little Java C wrapper where we say make sure that we're always using release 8, which is to say don't just set the source and target to 8, but also specify that you must we must build assuming Java 8 modules, which is to say they don't exist. Technically, this check is no longer required because everything is Java 9+. We have moved the minimum version required up to Java 11 because that's what Clojure and Jackal are using. But I imagine that pretty soon we're going to have to bump that to 17. We're trying to get caught up with everything else as we can, and this is one of those steps. This is one of those very irritating steps. So the goal for today is to work on understanding how JLink works so that we can say there is a JRE. We always pull down the JRE as part of every build. This is the JRE built by Jackal itself. And we have the various bits of bytecode for it, all these Java files, the JS files, and then somewhere we've got the actual bytecode. This is not it. This is the JS zip. There's a sorry. This is the JS zip for the JRE, and somewhere around here we have a jar for the JRE. And we need to say, well, what if I also need Java IO data input or Java Neo byte buffer, and I need to add something else to the JRE that's not present? How can we tell the Java module system that there's new classes and we want to allow them? Are we going to need to remake the base image whenever something gets added? Or is there a way we can say, actually, let's bend the rules a little bit and let us continue to add things to the base image? And my hope is that it's the latter. Just like most of us do in most of our projects most of the time, the whole module system didn't really, I think, live up to what people had expected, unless you're writing a desktop app or something that needs to be distributed with a very small footprint, where you want to strip down the JRE or the JDK itself into something like a JRE, and you want to strip down your dependencies so that they only include the things that are actually necessary. In order to do that, all of the work for Java 9's, Java Platform Module System, JPMS, I believe that's what the acronym is, or initialism. All that was required, but most applications end up just treating it like an annoyance and needing to add the various add opens or add exports or whatever calls to make things work. We don't have any of those in here because this itself doesn't need any, and we don't do any reflection that pokes holes in there to say, hey, I want access to something that I'm not supposed to do. So we're going to spend a little bit of time today understanding what JLink and JMod actually do. I think JLink is the main thing we need here, but we're going to have to look at JMod a little bit and figure out what exactly it's doing here also. Because Jackal, when it builds its own JRE, it replaces the JDK system module so that it can build on Java 9+, and it can change some of the Java classes. It can build its own. Let's look at the actual examples here. It can declare its own JavaLang class and its own JavaLang object and things like that. Object. This is in the package JavaLang. It's not super sourced like GWT does, where we just say here is the .java file, which is what this is here, but it actually emits a class file, and then it requires downstream projects to depend on that class file and use that class file bytecode. But if there's a method missing from here, it needs to be missing, and if there's an extra method, like this magic little guy here, it needs to be present. So yeah, let's take a look. I have done very little prep for this, so this stream is going to start off with a whole lot of I don't know what's going on, and we're going to experiment. We're going to take a look at what's happening there. We're going to try some manual experiments to build our own JLink modules. And if those manual experiments go well, we will see about incorporating it over here into our own Java C and try and decide where in our build setup do we need to specify this. So chances are, I'm hoping that we can just say, let's repackage very slightly how the JRE is built to allow other jars and other modules to contribute to it. And if that's possible, that'll save us a whole lot of work. We will do basically nothing here. This will all live in Jackal itself. Let's see, which branch are we on here? Looks like we are on Google's own upstream, probably not latest. Let's make sure we don't have any changes. We do have changes. I was trying to fix tests because Google checks in broken tests because they are Google. They can do that. Let's just reset hard. I don't care about this. We can revive it later. One of the Googlers who works on this put a different way to do the same thing, fixing the same problems that we had pointed out. So, as discussed in the past, we maintain our own branch. We are a little bit behind right now. We're hoping to update whenever they tag. However, they tag infrequently, shall we say. And here's all of our commits up until we get up to Google's tag. These are all the various changes we need to do. Most of them are about the POM files that we add and the build wiring to make this all work. But a handful of them are specific changes to how Jackal itself works or exposing some internal APIs that we want access to. So once I'm on this branch now, we can take a look at how we build some various things. The important stuff includes the JRE. We have a specific assembly file here that says, let's see, it wants a zip and it just includes, Oh, I see. This, despite being named jre.js, and there is a file called jre.js, this must be a directory. Let's confirm that real quick. Otherwise, I'm going to get irritated later. Java jre.js, which contains Java code. And these are all the JS files, their source maps, and then the original Java that the source map maps to. 2 weeks ago, prior to me being out, we took the time to say, okay, given this source map, and given the fact that it maps to this file here, what if we load this file into here? So we effectively have this, all right, it doesn't want me to edit that. It has a source contents section, which contains these files. That way, instead of loading 2 files for every one of these, we load 1, and then we take all of those individual source maps and bundle them into one big piece. Dimitri has pointed out that he is still encountering an exception in building, actually in rebuilding. I can't reproduce it yet. I have not gotten his full behemoth of a project working. That needs to be on my to-do list. But the long and short of it is that even just the small steps toward this have increased the build times, the CPU time, by, I don't know, I didn't measure exactly what the time was, but it ended up with a net decrease in total build time of about 20-30%. And I think that the second stage I did will subtract another 20-30% also. So hopefully it will dramatically improve performance of using Jackal Watch and incremental rebuilds. Excuse me, just 1 second. All right. So anyway, that's all this stuff here. I don't think we have a specific jar that I need to look at specifically. Let's see here. We say here's libjre, which is our pre-built JRE. I think we're going to peek inside, see what's in there, and then all the sources are in there. So we tell Maven, hey, I've got this Java file, or this thing here I want you to recognize as Jackal's JRE. Here's all the sources that someone might need. We don't do Java docs. We must have some hack in place for that. I know we have a hack in place because you can't deploy without Java doc of some kind. My notes say why. What we do instead? Incorporate Javadoc into the Bazel and Maven builds. Also update the root POM to include specifics that Sonatype will require for. Well, we must have something there. All right, I'm curious, so we're going to investigate real quick before digging in here. Here's our latest tagged version. There is a Javadoc jar, but it's empty. I think that's the empty size for a zip. So I must be doing something clever to say, hey, here's an empty Javadoc jar. Empty Javadoc jar. Okay, cool. So what this does is it's just a specific execution that says make a jar of the sources you have. You may note there are no sources. There's just a target and some other files. And mark it as the Javadoc jar, and it's empty. Which is fine because anybody in any reasonable setup is probably using their own JRE locally for Javadoc, and that's how GWT expects you to behave too. It's not going to have anything automatic for you to say, oh, well, let's look here at how object is defined and what the Javadoc for object is, because there's nothing. So, all right, we were going to peek inside this jar and see what's in here, and see if that's the thing that's actually already made into JLink magic. We'll take a look at that too. So let's do an unzip L on that. And it doesn't exist. Okay, let's do a build then. We've got build. This may take a moment, may require a clean. So let's peek around while we wait for that to go. Like I said, minimal prep for this. Let's also pull up some docs on what JRE or what JLink is supposed to do. Can I type, please? Thank you. Unfortunately, or fortunately, Bazel is eating 98% of my CPUs, which is 32 of them, which is kind of impressive. I just love compiling a new copy of Protobuf every time I need to build anything. It's not like I'm actually doing anything else with my system. So we're just going to wait. There we go. And hope that that RAM number doesn't max out and kill off what little bit of swap we've got left. I don't have a ton of swap configured. Yep, C++. Gotta rebuild that C++ every time we build. Thank you for that. Okay, Jmod. We're gonna look at this. We're gonna look at 20 just in case it's not the same. We are getting perilously close to out of memory, but we're not there yet. I did not start my captions. I was going to say, it's a good thing I'm not running Chrome, but I am running Chrome, just for the sake of captions. There we are. Because there goes the rest of the memory. Okay, looks like it's gotten past that point. It's starting to actually build things. CPU usage is still pretty miserable, but not so bad. Okay, you use Jmod to create Jmod files and list the contents of existing Jmod files. This is the Java 11. Maybe Java 20 is better. Create Jmod files and list the contents of existing Jmod files. Thanks. Create, extract, list, describe, hash. We have options. Deploying modules on the module path or publishing them. Continue to package modules in jar files. Okay, the Jmod tool is intended for modules that have native libraries. We don't. Or configuration files. That's a pretty broad brush there. Or modules that you intend to link. We do. To a runtime image. The Jmod format lets you aggregate classes other than Java, within class, metadata, and resources. You just said configuration files. The configuration must not be resources or metadata. This format is transportable, but not executable, which means you can use it during compile time or link time, but not at runtime. All right, build is successful. We can take a look at what's in there now. Or we cannot, because I'm in the wrong directory. I am expected to be in something else. So this probably actually would have worked before, but we're dumb. So with the hash modules option or the hash command, you can in each module's descriptor record hashes of the contents that are allowed to depend upon it. Ouch. Thus tying together these modules. This enables a package to be exported to one or more specifically named modules and to no others through qualified exports. Interesting. Like friends, I guess, but for Java. The runtime verifies if the recorded hash module matches one resolved at runtime. So how do you have the hash if it doesn't depend on it yet? I guess you have to build backward or something? That's interesting. Yeah, Okay, so we got a bunch of args here. We're going to take a look at what args get passed into JMod here. Looks like we grab the JLink version, and then we use JMod. We create one. It has the version that matches the JLink version. It only works on AMD 64. Thanks, guys. At least, okay, so it says that. But there's actually going to be no contents in here that are specific to AMD 64, so it might just be I have to put something here, so I'm going to put that. It would be nice if this was configurable to say either I can do anything, or actually, I run in a browser. Class path, you give it a set of classes, which is interesting. I wonder if it actually incorporates that, and then it produces this module.jmod. Let's see. Does that get built anywhere that we can see? I believe we ran this as part of building the JDK itself. Let's see, this is the JDK system rule, which must be used here, which is invoked by this. And this is the JRE Java. Oops, wrong button. JRE boot class path. Do we have a boot class path bit of wiring for Maven? It's been a long time. I think we do. Java-C bootstrap class path, which is libjre boot class path. Okay, we're running that too. So maybe this is the JModded thing. Looks to be pretty close to the same. That's interesting. Let's see, meta-inf and a manifest. The other one had a module info.class, and this one has a module info.class. Let's see, total size 1378497. And 1378483. So just a very few small more bytes in this one. Very, very close. We can diff those files if it comes to that. Let's understand a little better what's happening to this JRE boot class path. Is this used to build the JRE or vice versa? Here's the JRE itself with some custom options. Here are their options to say, hey, I'm patching a module, Java base. Make sure Java base could be redefined since we are redeclaring files for a Java base. Okay, so this is the argument here. We want to make sure we're passing into Java-C in our own Jackal Maven plugin, right? This is the fundamental thing. And the trick is, I guess, we need to say, so we already tried this once, and it didn't work, right? Because this code is ancient, relatively speaking. System none to say, hey, I don't have anything else at all. We don't need to worry about split packages. We're going to allow every single module to patch Java base. That's our real goal here. We want every single module to be able to patch Java base, because then anybody can contribute what's effectively super source to emulate whatever they need. Java Neo is the big one that at least Dimitri and I are after. I know some other folks are after Java Time. Any of those things in Java 11 and beyond, right? Because it defaults to Java 11 now. We need to have support. So let's see. So the first obvious, simple, maybe will work thing is just to say, let's add system none and patch module Java base. So we're just going to go ahead and remove that and replace it very simply. Which branch am I in? That one here. This is our service loader branch. Wow, that is... Make sure we're up to date here. Make sure we didn't add any new changes. No, okay. Let's do Java-C options dot add all. let's see, system none, and then patch module java.base. I am 90-something% that this is not going to work. String concat inline. So this is a funny one. I actually just hit a bug in this. All versions of Java from 9 to what, like 21? Yeah, the early versions of 22 are bugged here, where there's the compiler hits a problem as it starts building this instruction. So that seems like a reasonable thing for us to exclude anyway. But it specifically says, okay, we're not going to be synthesizing bytecode on the fly that will make these calls. We could also just go ahead and introduce the API calls, which we won't use anyway, so it doesn't really matter. Remove warnings that are not relevant. This is error prone. We aren't using error prone. And that's all the custom stuff. So they must be adding this at some level to non-JRE code too. Okay, every single... Yep, here it is. They default to add that. And then they also have this XD inject log sites false, which is also unsupported. Interesting that they don't have that here. Wonder what that's about. Anyway, we're going to grab that too. As long as we're updating, may as well steal all the good stuff. We want a Java version flag, I think. What are we running right now? I'm on 11. Let's leave that at 11. That seems okay. At some point, I'm going to want to kick this up a little higher, but I'm pretty sure that Jackal itself can only handle 11. It doesn't have support for newer bytecode, and doesn't have support for newer JRE stuff. So just leaving it at 11 right now will make sense. So actually, let's go ahead and also add... For right now, we will make this configurable in the future. Just hard-code it to 11. All right. And this is all they do here. But then, oh, and look at that. They do then add this here. That's interesting that they add that in different places. JRE Java C options equals those other options plus this. Does this get referenced somewhere else then? That's what it seems to imply. It does not. That's weird. I guess it feels very Python-esque to just, randomly generate garbage. But it's weird to do that in a build file in an ostensibly declarative language. Anyway, I don't love Bazel. It's cool, but it's a pain. Okay, so this is how we build this. We don't care about WebAssembly today. That will be a I would love to care about it thing, but I don't have time for it right now. Here's how we build the JRE itself. There's 2 more usages we still got to check out. This is not using the newly built image down below. And here we take the JRE Java files again, the same Java files, and compile them differently, except, oh no, this is still Java library. We have some visibility thing, only visible to this package. Has some dependencies, yeah. And then this library is dependent on here. So it has the same source as Java C, plus or minus anything? Is it exactly the same? This has native files. I must have misread because I thought for sure it said that it was smaller. One 1378483 is bigger or smaller than 1378497. So this is bigger. The bootstrap is bigger. Exactly the same number of files. The JRE Jackal library contains native files, which are non-zero. Maybe it just doesn't pass them into the Java library rule. libjre underscore boot class path. Libjre is generated by this, right? Libjre comes from here. There we are. Which is going to invoke Java home or Java library at some point. Probably here. I don't see a Java home yet. Probably deep in here. This is probably not worth our time. But here we are. And it just says it exports it. Let's back up. File. Well, read the docs. It says it right here. In particular, the depths this rule needs for reference resolution are Java library targets. It doesn't explicitly say that it runs that. Okay. Anyway, we're getting distracted on an already massive topic. Let's back up to here. Great. This is perfect. Okay, so this very slight difference in size would be fun to explore. This is the one we want. We don't care about this one here. Note that these two targets are separately compiled as a Java library to avoid circular dependency with what? Not with each other. What depends on JRE boot class path? Two things do. It looks like it's the same file. It's really irritating how it's rendering this. The transpiler imports the JRE and then uses it to build a JRE bundle, which it depends on the boot class path and libjre. Okay. And then there's a Java binary that to create a merged jar of all depths of the standard runtime. In the transpiler package? Let's see, this is transpiler slash... Oh, this is Java tests. That's interesting, that the tests do their own thing here, and then nothing uses this. Okay, some things use this, they just don't reference it nicely. Yeah, because they reference the deploy jar, which is an implicit thing that's created by making a Java binary, giving it a name, and then it creates this, yeah. Love Bazel so much, and all the tooling around it. Okay. But still, important to note that it's only for, let's do the open find window so I can see the file hierarchy. It's only in these files here, which are specific to tests. So in short, we don't care. Okay, who else uses this? This one does. The Jackal Java toolchain uses this, which is this magic thing we already looked at. Let's see, you give it a name, you give it a boot class path. Someone's yelling at me. Is this important? It is not important. Thankfully, I got a notification that a channel that no one has talked months was archived. Okay. It's just going to pass it the boot class path. It's going to give it a name, and then visibility just for this internal junk. We'll chase that in a little bit. Let's look for this name here, Jackal Java Toolchain, J2CL Java Toolchain. Doesn't look like it actually builds any artifacts here, but it's possible we just weren't depending on it. So let's go look at Jackal Java Toolchain, default Java Toolchain. This is the thing that's supposed to... Nope, there's no actual calls here being made. I missed something. Let's go back. JDK system. Here's its actual body, which is this Python-ish def here, which is the thing that will invoke make a temp directory, stick the jmod in the temp directory as module.jmod, and then it references the directory that that's in as a module path, add module. Again, disable system modules. So JLink is told somehow grab this jmod, which has classes in it, and then link it into an image this way. And then this is the weird one for me. JRTFS, copy it into our new module directory. And our module directory is whatever's passed in here. Oh, it's some declared output directory. Okay. Java base is the real Java install. So we are going to go ahead and grab parts of the real Java install and put them into here, which seems weird to me because we don't seem to use it. Did we used to? No, it doesn't look like it. And then we blow away temp. Yeah, I'm not sure. Let's look one more time at jmod here, because it seemed pretty explicit that it's for other than class files, but perhaps you can still aggregate class files in there. All right, so what's the output of a JDK system? A JDK system will say, here's my implementation. It needs to already have a runtime, it needs to have a zip tool, and it needs to have the boot class path. The boot class path is going to get passed in, I assume, as an argument to implementation. We got context. Yeah, boot class path, so this is declared as a file. Boot class path is consumed here to say zip, which is jar, I guess, technically. Maybe. X. Here's your working directory's boot class path. Or unzip, I guess. That's what X is going to be. Unzip all that stuff into classes. So grab our boot class path, unzip it into here, jmod it, and then jlink it. And it is assumed by me, at least, that if we jlink it, it's going to produce something that this JDK system will have as output. And for the moment, though, this is all I see from that Jackal Java toolchain. Oh, here's a directory. Jackal Java toolchain release. What's this? It tells us what version of Java and what modules it came up with. And then lib, this is the copied thing. And then this file here is probably a zip. Let's poke it and see what it is. I put something. Oof. It's all the way. All Java toolchain system lib. I want modules. Well, that's interesting. I just went with that. It is not a zip. So it's something else. It outputs it as modules. I've never done this before, so forgive me if I'm being stupid. And someone else can say, hey, you're being stupid. Here's what you want to do. So JLink outputs into the module directory, which I guess implicitly creates a lib, because then we're able to copy it here. There is no other reference to lib, so this must be automatically making that. It doesn't seem to make anything else. So I'm guessing you give it this directory. It creates the release file, the lib directory, and the modules here. Let's go back then and look at JLink and what JLink itself is going to do. That's the Java 11 stuff. Come on, clicky. Description, the JLink tool links a set of modules along with their transitive dependencies to create a custom runtime image. So by set of modules, in this case, we mean exactly one. And apparently disables a plugin which says go grab the system modules. That way we can do our own thing. So I am assuming that this song and dance here is not sufficient to pull all this stuff together. That we can say, okay, I want system none, I want patch modules, and all this is going to work if and only if we have already produced a custom module to start up with. We are not going to have our own. See, this is the boot class path that we already had. This is it's being fed in from the build mojo. We have this hard-coded here, but these are all defined as parameters, by the way. So if you want to replace the bootstrap, you can just go ahead and specify, hey, here's a different group ID, artifact ID, blah, 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 that you want here, or a different version. And likewise, the JRE is you can specify your own version for all that junk. So we have this bootstrap class path and the bootstrap JS zip. That's interesting. We don't use the bootstrap class path directly. Do I refer to it by name, maybe? Yeah, okay. So there's this extra bit of garbage I have to do to say, hey, here's how you're going to read this and inherit it from the particular module you're currently building. Someone directly uses this, though, probably as part of how it grabs, okay, extra JS zips to go and load them. All right, fine. Okay, so like we said, this is almost certainly not going to be sufficient. But we sure could try in the meantime. Let's just do a clean just in case. I bet I got some old garbage in here from previous attempts at stuff. Entirely unrelated stuff, and unlike our lovely hermetic build systems, or nearly so, Maven doesn't know when to clean up its trash. So we'll see how far it gets. I don't think I have any good tests for Java 8 stuff. I'm sorry, for Java 11 stuff. So we probably aren't going to hit any. Oh, that's okay. We're already hitting failures. Cool. A failure anyway. Let's go look at what happened. IntelliJ really doesn't like this part because I'm making so many files and so many directories. I'm sure my SSD doesn't love it either. POM replacements has a build log. Go and download everything. And then it's complaining about cannot find symbol. That's a little weird. Why? But Elemental worked. Transitive dependencies is also failing. POM replacements is a weird one. I don't even think that's checked in because it was an idea of a feature that I never rounded out. I mean, it is explicitly labeled as broken. All right, so this is a pretty good starting point here. Let's look at Java assertions. That's a real well-rounded. Do assertions work or not? Is declared in the unnamed module, but this module does not read it. Okay. Does that mean that we have module files in the JUnit jars? That's what it looks like to me. Let's look at the JUnit. Let's see, which one is this? This is the JUnit app stuff. Emulation. It should be a processor instead. It's just emulation here. I don't see any module junk in here. It's possible I've got that disabled, so it's not copying it, but something is noticing it and saying, hey, I hate you. Is declared in the unnamed module, but this module does not read it. Let's look in Jacklet's help. Google JUnit. That's weird. There's no Google JUnit Jackal JUnit. That must be the module name. I'm doing something dumb, and I'm going slow now as a result. This is a package. Here is the package itself. This is processor junk, so let's just go see where this stuff lives. This is probably all in the same JUnit generator. Okay, so I went into emul instead of generator. That's the problem. I don't see any module files in here. Is something explicitly declaring this as a module? I mean, it's building it for Java 8, so it's still runnable, right? Additional yelling is taking place. User who didn't read the instructions didn't have it work properly. Yeah. We can. This doesn't matter for this conversation. All right, well, let's peek in the actual installed jar to see if there's any module, because it says it's declared in the unnamed module, but something doesn't read it. It might be because we are running Java C with some particular flags that it says, oh, well, you must have said you are using this module. I bet that's it, actually. I bet that by virtue of saying I'm patching a module, I am saying I am participating with the whole module thing. All right, so this will take 2 minutes to get that far to fail again. I'm not opposed necessarily to saying, hey, we're part of a module, we're going to use a particular module. But it does sound like it's going to cause other headaches. We're going to need everything to say, hey, here's a module, and here are the modules I depend on. Maybe we can synthesize modules as we go, but that just sounds like trouble, because odds are at least one person out there somewhere who wants to use the Jackal Maven plugin is going to have a jar with modules in it. So modules, the whole point of them is runtime checks, right? It doesn't really care about the compile time stuff so much. But the runtime checks that it's doing are going to be all about, oh, it looks like you can't actually do a reflection error. You can't link against that thing there. They at least need to check runtime stuff. There is no Java runtime when Jackal is doing its thing, because Jackal emits code that runs in the browser or some other JavaScript or WebAssembly runtime. Even if you compile your Java to Kotlin using this tool, it is not going to assume that it's a regular Java environment when it's all done. I have to assume that the module system doesn't apply to Kotlin stuff, because that would get weird with the JRE emulation. Okay, so that seems to have fixed this to say, hey, please don't worry about my module garbage, just let me do whatever. The important question now is, does it do what we want? I'm suspecting the answer is no. Let's make a new, it's going to take so much longer to make a new project. Let's just hack in an existing project. Let's pick a file that is not present in the regular JRE emulation. Yeah, I know. It's okay. So let's put something in the Java packages that are missing from Jackal, like something really, really dumb, like JavaX annotation generated, because they have the new processing one, but they don't have the old JavaX annotation one. I don't seem to have it here either. There we go. So for myself, I have this in JSR 250 because I pull it in from there, because newer versions of Java don't have it, but it's a thing that can exist, and it exists in JavaX. We could also look for something silly in Java 11 itself, some class that's missing, some interface that's missing. I'm sure clonable, for example, is already there. Yeah. How about an IO class? I've been doing a little bit of work trying to get the Java version of flat buffers to work. I mentioned this previously, and it is quite a bit smaller compiling out flat buffers than using the JavaScript version and asking it to compile it. Even the pretty version of GWT produces smaller flat buffers than the, hey, let's run Webpack with bells and whistles. Whistles and bells are not so great, it seems. Okay, let's look at git.co.js flat. Sorry, is it JS flat buff? Yeah, it's JS flat buff. And then we'll look at the files I've created. Tests are chugging away. I'm going to go ahead and stop that because it's just going to chew up time. Oh yeah, we can make reference. That's a fun one. It's not hard to define your own weak ref now, and we can make reference queue and soft reference. Reference queue is a simple implementation. That'd be an easy one. I've merged that in. That's really boring though. These are other changes. We want the emulation changes. Byte buffer input stream is something custom here. Collection util. I want something that's all green and small. It's like a puzzle. This is main junk. I want commits on this green line over here. I don't get a lot of chance to work on this project. Let's see, here's some emulation in here somewhere, I bet, in the web directory. Data input, EOF exception. There we are. 10 lines of code. Bam. That's our new emulated code that we're going to add to Jackal in our own project. The sillier, the better. Okay. Let's make a new file. This will be called java/io/eof exception.java. That's weird. All right, the issue we're having is unrelated. Okay, it's just a Jackal issue. Somebody in the Jackal chat is having a problem. I was suggesting he'd come hang out and we can bang on it together, and he can show off the cool things he's doing with JavaFX in Jackal and in GWT. But we're not going to do that right now. Right, let's try again. Obviously, I did something wrong. Java, IO, EOF, exception, Java. There we go. We'll just go ahead and add that for now. We'll add this here, put a close brace on it, and now let's change this invoker command to just build hello world single. All right, it failed, which is fantastic. At least we've got a test case that we can work with now. We could actually, I guess, look at the build log first. Package exists in another module, java.base. Yes, it does. That's why we're going to want to say, I want you to let me do whatever I want there. Which is, I mean, this makes good sense. So if we're running Java 11, we already figured this out. If we cd to, let's see, Jackal, Maven, plugin, target IT tests, hello world single, and we try to run, let's see, what are the args of Java C? So rarely do this, because, you know, there's real tools that'll do it for me. Let's see, generated class file, so we're going to do something like java c-d target classes. We're going to add some of our arguments we've got so far. We did release 8, so we're just going to test that out real quick. And then we say my input is source main java IO. Unrecognized option, right, because I didn't say Java C. Right, so that works. And then we kick this to 11. And it says, oh, okay, can't find symbol. Okay, so that's interesting. But first we got the expected error. Package exists in another module. Can't find symbol. And what we want to do is see if we can't find symbol. Interesting, so we'd have to redefine IO exception itself. According to this. It is interesting that we didn't get that logged here. Let's look just to make sure that there's not more logging happening in here. Nope, just one. It only logged the one. That's interesting that we get something else when we build from the command. Okay. Let's tag in with the other args here and see if any of them make any kind of a difference. I'm pretty sure system none is more about what base image do I get. Oh, system cannot be used with release. Interesting. Okay. That's good to know. Cannot find package Java lang in class path or boot class path. Okay, so let's pass it the boot class path. The already built one. Boot class path. We're going to go to workspace, Jackal, Bazel, bin. Let's go over here and look. I already did this. Here we are. Jerry, Java, Jerry boot class path. Delete, paste. Boot class path not allowed with target 11. Hang on. But you just said. Does it just go on the regular class path then? It's been a while, guys. Let's look at what is happening here. Oops, this is the wrong project. Sorry, got distracted. It still has my terminal history though, so it does what I need. It's just not what I really want right now. Let's see here. We want the build file for the JRE. Yep, JRE Java build. We want to say, how did you actually build all that stuff here? Here's the package sources. Here's the Java library for annotations. This thing gets consumed here. This thing gets consumed here. And this is what produces our JRE library. Okay. So there's basically just those options are enough to say, hey, I'm a compiler, I do what I, or I'm not a compiler. I'm the Java runtime, I can do what I want. I had reads. Oh, we missed this before. allow JRE classes are allowed to depend on JS interop annotations. It's interesting because I thought this, oh, it's add reads. Okay, they can read other things. I see. So we're going to want to add reads and add opens, I think, pretty much across the board. Okay, thanks, Jay Hillbounce. Nice to see you. I'm glad you hang out. Love a little more chatter here to get me distracted with stuff people want to hear about. I personally love to work on the Jackal stuff, as much of a headache as it can be, but the Java stuff, the GWT stuff is a lot easier to contribute to, and I think makes a more real impact, especially now that we're getting Java 17 stuff working. Anyway, but this is fun to experiment with, and this is a part of recent modern Java that I have no experience with yet. I am being super careful with how I hold my cup so that it doesn't, bother the camera, but the camera's not working. Bruno in Jackal chat says it's not working, so I've got one copy of the class and one module. Yeah, I'm trying to point them at the build log to say, here's what you can find. Output.log. All right. So we're going to keep hacking this command here to see if we can make it make something useful for us. So if instead of boot class path we said -cp, and just say, well, maybe boot class path doesn't exist anymore, we can just say class path now. Unable to find Java lang in class path or boot class path. Did I do something wrong here? Yep, there's all kinds of Java lang in there. Class files. System none. CP. See, this is the problem. This is the fundamental problem. How do you allow Java-C of a newer Java version to allow you to define new classes for Java itself? And I am obviously struggling. So when Jackal produces, that's the wrong thing. I'm just going to close this now because we're not going to use it today. This is for producing the JRE itself, right? Once the JRE is produced, it is consumed by all kinds of downstream things. It is automatically added as part of Jackal library. It is a Jackal library, but it's added to other downstream transitive Jackal libraries. I guess the boot class path must be also. Let's see, JRE boot class path. We found two places where it's referenced. One is tests, and the other is here, where we would build the tool chain. Let's just find references, or find strings for that. It is irritating that the name of the target and the name itself is the same thing. That's going to make it harder to find this. Internal do not use. Okay, so we definitely want to use that. Here is the alias to the thing itself, which thankfully has the same name, so someone else also have an internal do not use. Here we go. Here's the reference to your Java toolchain is internal do not use. There's the toolchain, which means someone is referencing Java toolchain in other places. Toolchain attributes, Jackal Java toolchain attributes. This is not the same. Let's see who uses this. It updates it into here. Oh, good. I'm glad we defined it in 2 different dictionaries, so we could just merge them. That's it for that. And then we load it from there when we build Jackal Java library. And then we reference it here. We merge it into here to say, hey, here's your attributes. And Jackal import. We're not doing Jackal import right now. I don't think we need to think about that to make this work. The attributes will go into the impl of Jackal library, context.attributes to get merged into here. Now I get lost. Jackal common dot compile is going to get the whole context. Jackal common is here. Compile is here. Context. And then we do just a plain Java compile here. If not has Kotlin sources. Avoid Kotlin for regular targets. Okay, so this might be where we actually call Java library. And I got to work backward to remember how we actually defined this to begin with. It's up here. It's here. We said here is the target that says it's our Java toolchain, whatever this magical target was. And it's the directory that it ends up making. It's that magical directory with the modules file in it. We'll use that as if it's a Java toolchain, I guess. Java toolchain JDK system. So it has this release. It has this JRTFS, which we have to reference, and it has this module. So this itself is a Java toolchain, which gets used somewhere in here. And I don't quite understand what this is doing. It's passing the whole thing into Java compile, declare file, strip annotations. This is pretty sure this is disabled in open source junk anyway. If that is none, then we build that. No, sorry, if it's not none, and we default to none, and then we'll go ahead and call Java common compile get Java toolchain. Hey, there we go. And this is where it indexes in, I think, and grabs our Java toolchain. Okay. So I don't know what Java toolchain does when you pass it to Java common compile. I'm guessing Java common is one of the built-ins. And you can just say, hey, here's the toolchain I want you to use. So the question is, do we need to actually specify a toolchain, or can we just get by with just an image or just a module or just a jar? An image would be the entire thing here. This is, I believe, an image, because this is what JLink created. The module would presumably be just this, although it got deleted when it got put in the temp directory. So maybe we could experiment by making our own module. That's going to be the next piece here. And then make our own image. And then see how we pass our image to Java-C. Has somebody done this before? I'm sure somebody's done this before. I believe, in fact, this is how you produce a JRE, by saying, hey, I built a JRE with Java-C. Now I would like to JLink it into a thing that I can give other people. So, So this is how to make one. Module path, add modules, limit modules, output. Oh, hey, okay, so this is some of the helpful stuff. The generated image will have the following layout. We don't have that, oddly enough. We just have a lib, which has modules in it, and we have this release. Okay, so that's there. Conf. Okay, so these are specific things from your Java runtime, I guess. Let's take a look here. This looks like it's just regurgitated garbage to me. But we'll give it a chance here to see if there's at least a hint in the right direction. So that's the native files in the lib directory, but we've got jars and the module thing in there, which doesn't seem to be referenced here. Here we go. The release with the special modules property. The release file has the modules property space-separated list of modules. This is topologically ordered according to the... Okay, this is actually not terrible. Somebody understood part of what they were doing as they were writing it. The samples directory was removed by this. So our case here... Oops, that's not what I meant to do. That was a giant mistake. That's not going to work at all. Okay, so our modules is and only java.base. Yeah, it's going to be unhappy now because that's a big file, I think. Telling it to read it as text, it's going to be a mistake. So that's the special modules property we need there. Java base is always first. Check. And that's all we want to have, I guess. Okay, so this is not helpful, I think. Let's back up. To create and build applications. I want to create and build my own JRE. Custom runtime image. Yep. This sounds like gobbledygook to the people who are listening. It's nearly so for me too, so please don't feel bad. And that's why I'm moving a little slow. Okay. Let's just try hacking away at this a little bit. This doesn't work. Somehow, when you build your own Java code in Bazel with Jackal, it emits the right command to say, well, here's what you actually need to do. So if we looked at, I don't know, what's an example of something that is actually built as part of doing all this? If we look at like the hello world, maybe there's some leftovers that we could examine from when it ran Java-C. Because sometimes the way that Bazel works is it writes the parameters to Java-C out to the file or something. So this isn't it. This is passing to something else. That is probably not a text file. It's probably... Oh, it is. No, it just didn't open. Great. This is the thing that actually processes your JavaScript to make sure it makes sense. This is some kind of protobuf text, it says. I can't tell you more than that. Super helpful, I know, me reading what's on the page. Where is the actual class for the hello world sample? It is in main Java. This is my own hacking to say, hey, does this work? Spoiler, it didn't work. So here's hello world. So I'm looking for it in samples hello world lib. Here's hello world lib, which it needed to compile to bytecode at some point, which is how we have Oh, it didn't need to compile it to bytecode. So it sounds like we need actually 3 jars to make this work. We need the JRE built to, whatever. We need an intermediate dependency. If instead of an intermediate dependency, we just had an application, we run Java C on nothing. Because we just need to say, hey, Jackal, you don't need the bytecode for the application. You just need the Java sources and the bytecode of the dependencies, which in this case are just the JRE itself. But if you have an intermediate dependency, we need the bytecode of that. That way, the actual application can depend on the intermediate dependency and the bytecode it produced. So I guess my next question is, why are we even generating bytecode for the hello world sample? Not the hello world sample, the single hello in my integration test. It doesn't really matter, I guess, but I'm curious because I seem to have missed something here. It says it wants stripped sources and then it wants bytecode for hello world single, but nothing is going to consume that bytecode. Unless this is just the process of making sure. Yes, this is the process of making sure that annotation processors ran properly. There were no annotation processors. It didn't know that, so it had to run them anyway. Okay, so that's not the end of the world. We need a more complicated example then to get this to work. Say, hey, what are the arguments you're passing to Java C? And I'm frankly not real sure how to get that out of this. So what other arguments do we have to Java C? So that we can say, hey, here's your boot class path. Because it just told us, hey, I don't want a boot class path from here. Here we go, -- boot class path, override location of bootstrap class path files. Root modules to resolve in addition to initial modules or all modules on the module path if module is all module path. Okay. So just like -- add modules, all module path. I still don't understand why it lists this if you can't use it. Is this removed in like 21 or something? Oh, it's not that one. Sorry. I can't go back that far. Yeah, it doesn't allow it there either. Not release, it's source. Source and target. So it's specifically target that it doesn't like here. In platform classes, is that the same error we had before? Oh, that's different. That is different. Is this because we're passing system none now? In class path or boot class path? Okay, so the difference here and here is Java 21 versus 11. We still have the output directory. We still have system none. I'm explicitly passing target and source, so we'll go ahead and set that. We're passing the class path, but the error message is changed. Let's go ahead and explicitly set source and target. Yeah, different error message. Interesting. Okay. In platform classes, Do I need to somehow pass this as a specific module or something? What do you mean check timestamps? Compile only the specified module, check timestamps. Where to find application modules? This is, yeah, sorry, it's class files and annotation processors, right? Where to find application modules, where to find input source files for multiple modules. Interesting that the release stops at 11. All right. I thought that, oh, right, because I'm running 11. I'm dumb. Source path, system, override location of system modules, upgrade module path, override location of upgradable modules. Nothing about platforms. Let's, just in case. This is optimism on my part. It's a little bit different. Add modules. Root modules to resolve in addition to the initial modules. What is an initial module? Or all modules on the module path if module is all module path. Boot class path, which again I can't use. Class path. Directory, deprecation, enable, preview, encoding, endorsed. I thought that was removed. External extensions, debugging, native files, limit modules, module path, module source path, module version. Turn off warnings. We'll go back and check that, but there's no chance that was just a warning, right? And it was just doing what we asked. Processor junk, profile. Right, so this lets you oh, it's going to be removed, never mind. Release lets you specify anything up to 21 because I'm running a new version. S, where to place generated source files. Okay, annotation processors, we're not doing that. Source path, system. Yeah, it's the same otherwise. Just going to check one more time, go back and make sure that it is an error. Okay, good. So I'm guessing we need to actually specify a module path, or we need to understand what that tool chain thing is going to do. Because linking produces a runtime, right? That's the whole premise of it, that you're making a custom runtime. But this linked runtime here, is this the one I want? Yeah, it doesn't have a bin directory. So it's not, runnable. It has this JRTFS. I used to know what this meant because we dug around once and figured out what JRTFS does. Runtime. I could have told you that. It's pretty big. Just use this to gloss over it real quick. JDK internal. Oh, it's not that big. It's just JDK internal, JRTFS packages, and then JImage packages. And then we have a file system provider so that whatever Java is bootstrapped there can find this file system provider, which presumably will allow it to access things inside of there. But I'm not going to dig in and see what actually is happening here. Image reader. Okay, so presumably that's the guts to be able to access this module thing. And this, I presume, is the same. There's no bin in there. So how do you pass an image to Java-C? So this is probably not the same toolchain idea, because this needs to be a full JRE. Yeah, we're not building a toolchain. I want to use it in the Bazel sense as a toolchain. Okay, this is how to define your own toolchains, but I'm wondering about Java toolchains specifically, so I guess my bad. Something is obviously passing it in when we call... Oh boy, I've lost it now, haven't I? Here. Java Common Compile. So there is a Java Common Compile. Here's my toolchain. Do a thing with it. I used to know how to dig into the guts of Bazel to figure out what it was actually doing with some of these things. Toolchain, toolchain, toolchain required. A Java toolchain info to be used for this compilation. Mandatory. So you got more references on that since it's so mandatory, yeah? It has a provider. It has a parameter of info, the Java info. Well, there we go, guys. It's the Java info. You can merge it with other providers into a single Java info. Okay. You can pack sources into a source file, but this is our other parameters that are getting passed into here. So what is Java toolchain info? Ah! All right, let's see where Java common is defined. It's got to be in Bazel itself. Sometimes I just have to assume that Bazel is sort of a joke, or its docs are a joke. It only works if you already know how it works. I mean, Gradle already has that as like a feature. It's too complicated to ever understand, so just don't worry about it. Okay, toolchain. Toolchain is here, here, and it just passes it directly to compile. So underscore compile is just a proxy for compile with some, I guess, default args. That's super helpful. Compile is then defined where? It's probably imported from somewhere else. Yep, it is. Java Common Internal for built-ins Bazel. Good. I love indirection, especially in Python. I know it's Starlark or Skylark, whatever the hell they call it, but it's actually Python. Python, but without anything useful like a debugger. Not that Python's debugger is, useful. I forgot what I'm looking for. Java toolchain. There we go. It is the toolchain to be used for this compilation. Mandatory. Thank you. Okay, so now we know where that helpful documentation came from. Boot class path, if present, overrides the boot class path associated with the provided Java toolchain. Optional, but of course you can't provide a boot class path because that's not allowed anymore. Let's see here. It's going to do some check thing. It's going to append it to Java opts. Oh, the toolchain has a Java-C opts property. Is that all we do with it? We also say append this compatible Java-C options from these three things. We grab the package configuration. So somewhere we set Java-C options when we define it. And I don't know how to chase my tail backward to find this again. Java library, this is probably it here. Extra Java-C options is just this dagger junk. Great. Context attribute Java-C options. But this is, we're looking for the toolchain one, the one that's going to be passed to the created toolchain. These are extra. These are not the actual underscore property that we're looking for. So the Java-C options, well, I don't know, constructor. Sorry, I said Java-C options. I meant Java toolchain info. Must have taken some other argument when we created it. Yep, that's how you make the thing. Thanks. And then we define it to be this thing here, which is an internal do not use. Let's go to internal do not use, where it gets it originally from here. And then that's just the generated J-linked thing. So did the J-linked thing return something useful, and we're just going to chase our tail all the way backward to here again? It has other args, a boot class path, apparently that's a thing, still. It has a name. It just tacks JDK system on the end of it. Wish this had, like, how do you use it? It defines a Java toolchain for Jackal compilers. Boot class path, okay. Runtime. So it is explicitly setting a boot class path. It has a runtime, which is going to, I guess, default to the current runtime. It has a boot class path. Didn't we just say over and over, you can't set a boot class path? System equals system, and system is outputs, which is our path, I guess. That's the module dir where we build to. Okay. And boot class path is the passed in boot class path. So somehow when you construct this Java common boot class path info, you specify a boot class path, which it will then use here, I guess. Let's see, that's a boot class path info, which has a system and a boot class path. And this gets returned from underscore JDK system as the implementation. Does it return it? Yeah, it does return it. It returns this tuple-ish thing. I think this is how Bazel does tuples, or else you just return arrays in lots of places. I'm in the wrong place. This gets called from here, which doesn't actually return anything. That just means something for the build system to do something with. And then you pass in the boot class path. It's not consumed directly here, but this name is referenced here from default Java toolchain. Oh, hey, did we look at this yet? We might have missed this. JVM options without patching Java compiler. I think we missed this. Oh, this is from Bazel itself. I'm glad we found this. Oh, good. They just open up Java. That's good. That's really good. So this is all compiler stuff at the top. This is something specific for protobuf, that they're going to add these opens and just never notice them. Java 9 options, we're going to allow it to patch it, presumably for error prone. There's some bug here, I guess, that needs that. Base toolchain info. Hey, there we go. Okay, so here's our boot class path. Let's see, where are we right now? We're in tools. There's a JDK platform class path. That's actually where we're already in. It's in here, platform class path, yeah? There's platform class path. Okay, so that doesn't really help me yet, but it tells me how we define this stuff. How it's defined by default. Let's go back before I lose my place there, because I really wanted to know what else this is doing here. Turbine is not a worker, and parallel GC is faster for short-lived programs. Okay. This is, I see this is going to pass to be available for Turbine. I still don't understand how we generate the Java C options here. Which might say, for example, here's the path to the thing that I want you to use as my bootstrap. Boot class path info. This is for 8. Yes, we know we can pass it for 8. I want to know how to pass it for 11. I either want to know how to pass it for 11, or I want to know how Java C is being invoked as part of this custom image. How do you pass a quote-unquote tool chain to Java C to say, here's the thing I want you to use when you run, so that you know all about these particular modules. I want you to build against this image here. And this is ostensibly a tool chain, and a tool chain then can be used to compile stuff on. Is there a hey dump all kinds of more debugging stuff for me, please, command? I want to say it's like -S. Yes. So let's go to samples, hello world, Bazel, build -S, everything. We may do a clean first. Oh, good. It failed. It's probably because I got extra garbage. Well, I don't have the extra garbage yet. I really wanted to fail specifically the Java C bit. (220301). Oh no, it doesn't like something about Bazel comment. I don't have any changes though, do I? Bazel comment is not defined and referenced by GWT incompatible stripper. What, did they remove it? I hate this. But every once in a while you have to do a clean expunge so that it gets its head back on straight. Nope, it just can't find it. Oh boy. Oh, I don't want everything as the problem. I just want to build specific targets because it's going to try and build tests, and of course, you can't build Jackal tests in open source. Why would you be able to do that? This is actually a much better example here. Hello, Guava, because this will show us running Java C. Yeah, let's do that one instead. I guess there's a target in here. That'll be good enough. So let's do source main java Google Jackal samples Guava. Right? Just see what that comes up with. New. Okay, this might be too much output. It's possibly made a mistake, and we should be dumping this to a log file. I am not above running it again and cleaning and just typing it all there. Let's see, what are we doing right now? There's a bunch of GCC commands. Almost certainly none of this makes sense because you need protobuf to be able to do, anything. Why isn't there a shipped copy of protobuf in Bazel like there is an entire JVM? Is it because it's acceptable to rebuild protobuf every time, but it's not acceptable to make users build their own copy of the JDK every time? Is it because protobuf changes too often and is yet at the same time unmaintained for many platforms? Nobody knows. I'm sure somebody knows. I don't know where they choose to draw the line for this stuff. Well, this is okay to rebuild all the time, but that never is. All right, looks like we're getting there. Only about 100 more to go. Oh, good, the number is going up. I just saw a bunch of what looks like platform class path. I want to see that. Boot class path. Well, we're building the boot class path. Okay, so this is okay. We don't actually care so far. It's building Jackal itself at this point. Apparently it hasn't built the rest of protobuf, though. I'm just going to go ahead and get rid of the logs so far because this looks like it's still not yet interesting. It's running some very large Java C commands. Here's Elemental getting built, transpiling to JavaScript, and presumably also to Java. That way we can use them. Here's the JRE getting built. Interesting that it was able to do, well, I guess that sort of makes sense. It was able to build the elemental stuff first. So we want to wait up here and find one of these Java C commands. One of these recent little ones just for elemental or something like that. Here's a bunch of Guava bits of confusion where they've got JS methods that don't return any valid JavaScript type. Here's guava.js getting built. Okay. So I'm going to get distracted because, that's what you do. Let's see how big this is. 13 lines. I don't actually want lines. I wanted bytes. I'm used to that, though. Guava's way too small to... Oh, this is because it's the entire application. Got it. Okay. This is the baked down result. We want to look at the external Guava Jackal JS. I want to see what's in here. Don't mind me for getting distracted. It's what we do here. WCL. Just do plain old WC, I guess. Just less, that way I don't immediately lose everything. And there is just one. Oh, it's not going to break it down file by file. I thought it broke it down file by file. Oh, I didn't paste it. Let's try that. Nothing. No such file or directory. Samples guava. Is a directory. Is there not a recursive WC? Or do I just need to explicitly say it's recursive? Nope, you have to... My amount of stuff that I care here is going down. That is what I meant. There we go. That's what I meant. So just over a megabyte total, but we only wanted JavaScript anyway. Cool. Okay. Not sure how helpful it is, but it was amusing for me. Let's look for Java C commands. There are 127 of them. So this is invoking Java to do something. What are we doing? We are compiling Java headers. So this is running Turbine. Turbine is a Java compiler that doesn't produce runnable bytecode. Instead, it produces bytecode that only describes what you're going to be able to run on it. So it's kind of helpful in this context because usually that's all we want. It's also Java 8 specific. And Java 11? What the heck? Java C opts. And then it just goes on to adding source 11. So maybe it does both. It just concatenates more arguments on the end of it. And then there's this dash dash to say, hey, there's a break in my arguments for something. Back to Basel land, I guess. Here's the turbine binary itself that's going to run, -jar, which means it has a main. Everything before that is JDK stuff, like, hey, I'm going to patch modules to rewrite the compiler, and add opens and junk like that. Although these are probably mostly for internal Basel stuff. Output is where the file is going to go, the newly generated header bytecode. Boot class path. So Turbine itself takes a boot class path. Source jars, and then we pass all these options. Okay. I'm not sure any of this is actually helpful because we're not trying to figure out how to run Turbine. Dimitri did update Jackal some time ago to be able to, Jackal Maven plugin, to be able to run Turbine as part of its build. Let's show that. So we've got the bytecode task and the Java C task. The Java C task is deprecated. It doesn't do anything anymore. Instead, the Turbine task extends it and replaces its implementation with, hey, grab whatever. So if your version is 8, I guess, because we should just delete this, dude. We should just delete this. We don't care about Java 8. And then we can kill Java C task. Anyway, this is what we use instead of the Java C task, but our bytecode task is still necessary for building and rebuilding annotation processors on the fly and things like that. At least at the moment. This one here. This still uses Java C. We build our list of processors, we pass it to Java C. In theory, Turbine can also run our processors. In practice, it can't build them, so that's not good enough. Looks like this is Turbine again, I'm guessing. Promise Jackal, yep, header junk. At some point, it has to actually Does it not have to actually build using real Java C? Maybe not. Maybe their ability to partition annotation processors from annotation processors, by the way, which are real Java code, and you can just run them as real Java, from code which only needs to exist as header bytecode, and so you can use an alternative tool like Turbine and just completely ignore Java C and its restrictions. Maybe their ability to do that, which Maven cannot do. I mean, technically, Maven, you can say, hey, here's my annotation processor stuff. I'm going to put it in a separate source path. But and then add it to the Maven compiler arguments. But realistically, that's a load of crap because we need to be able to go through all the modules, and you can't just say, hey, while I'm running Maven, can you run Maven to go and compile that stuff? It's one of those ideas that sounds nice if you don't think about it, which is, yeah. Or you just say, sorry, that's someone else's problem. I guess if you use Maven, you can't actually do useful things, which is not helpful. Here's a much bigger build. Still headers, though. This is much more helpful, though, to being able to wade through what they actually do, and then we're out of stuff. That's the end of that. This is still a Java command, a bunch of JVM args. Here's a Java builder. I want to see that. libwasm jar 0 params. So I guess that Java builder might be a Java class in Bazel itself. That invokes the Java toolchain. So just for reference, the way that our own Java C type works is it builds a bunch of arguments, and then it produces a compilation task by calling JavaX compiler or JavaX tools. JavaX tools, Java compiler, get task, which produces this new thing here. And we want to bend the rules here a little bit and get it to run something different. Maybe they are already doing that. So let's look for something that looks like Java Builder in Bazel's own source. Nothing really looks like it here. There's a JDT one. I imagine that's what we're using. Which jar is this? We actually have the JDT core. I can't imagine that's what we're actually running. I imagine this is this is some part of Bazel itself. Sorry, I'm looking at the wrong thing. This is what I want to look at. External remote Java tools. And every once in a while, it just deletes these packages that it thinks we don't need anymore. Or has different ways of linking from different places. Remote Java tools. README. This Java tools was built blah, 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 blah. Not much. Java Builder. So there's the Java Builder, which is part of Remote Java Tools. Where is this checked out from? I think it already said in the README. Bazel build java tools.zip. There's a separate jar for the compiler. It's kind of interesting. I wonder why it has all that. All right, Java Tools. We're going to look for a Java Tools directory. And see if it's got something here that looks vaguely like what we're trying to do. Sure doesn't look like it, though. Java Builder. Okay. Oops. No matches found. Okay, so there is no class called that. Your dependencies are source Java Tools build jar. Wait, did I actually? No, I didn't open tests. Let's see. Build jar. Google. I really wanted you to expand that without hiding what I was reading right now. And without scrolling away when I... It'd be nice if someone at Microsoft knew how back buttons worked. All right. Build jar slash build jar. Build slash build jar. Right? This one here. Java Tools. Java Tools build jar Java. Google DevTools slash build slash build jar. Good. Love the recursive naming. That's the runtime dependency, so we can find the main we're looking for. Somewhere in here is Bazel Java Builder. Right there. The one that it said didn't exist. Sweet. Really? It's open right now, dude. I love the modern internet. Okay. Anyway, so this is the thing that's going to do the thing that's going to run Java C. Does this itself run Java C? Of course not. It's going to have to defer to something else. This is probably the thing that talks to Bazel. That way it can get work done. It looks like it's going to call out to error prone. So you've got some options to build. Parses the arguments. And then we'll do the configuring. So this is the build thing. I don't really want the parse thing. I want the build. The result is builder.run simple Java library builder. Let's go look at that. I like that. It is nice that I can click through this stuff, especially since Bazel and IntelliJ can't figure out where classes are anymore. I mean, at least Gradle usually doesn't have that. All right, let's see. Do we have any JavaX in here? Not enough. So either it just dips directly into error prone. Let's see here. Source compilation, source files is empty, it's okay, otherwise run compile sources. Compile sources is... Here. Java C runner is a Java C runner. There are implementations of the Java C runner. Who calls compile sources? They pass in a Java C runner, which is Blaze Java C main, :compile, which means it is a static method somewhere in here. This looks a lot like what we're looking for. Magical class loader to grab certain things. This looks like how we're going to build our file manager for where we're going to put stuff. Boot class path. This may be empty if a release is being used. Okay, great. So they are putting their boot class path into platform class path. That's interesting. Platform class path. What the hell is a platform class path? So when we do this, I set up a source path, class output, but there is a platform class path. Let's see, annotation processor module path is 9. Location to search for platform class is sometimes called the boot class path. Okay, so, but again, this is nonsense, apparently, when you use Java 9+. Location for system modules. Apparently that's a magic path you can pass in. Standard location system modules. Yep, there it is. So how do you specify system modules or platform modules from the command line? This is the wrong project to do. Oh, it is the right one. You can override the location, and you can either say, here's a JDK, or it's none. So does that mean we can just say JDK instead of none? We just give it the path to the bootstrap class path thingy? And I'm assuming I don't need this class path at all then, because it's part of... We'll put it back, of course, if we screw up. Let's get rid of system none, and we'll change it to a different path instead, like... I'm over on the Jackal screen, sorry. Basil bin, JRE Java. Here's our toolchain. So we're going to copy an absolute path. Okay. I mean, different. Not helpful, but different. I don't know if it actually made a difference by passing that, but we still want to say, hey, let me do whatever I want to. So now that we're passing that, maybe we can get back to, hey, can I patch Java base? Patch module java.base equals with a B. And a dot. It worked. Okay. It worked. Let's think about this. What was the sticking point here? It was specifying an actual system instead of system none, I think. So let's work backward. If we specify system none instead of our special J-linked image, it doesn't work. So we need our special system and patch module base. If we don't specify, sorry, let's do this again. If we don't specify any system, so we use the default system, but patch module base. Oh, it still lets us warn. I'm sure we've tried this. System path not set in conjunction with source 11. Why would you need a system module path set? Why would you need that? Let's think about that. System modules path not set. Oh, because, of course, you need it because we're saying, I'm only telling you what bytecode there is. I'm not telling you, sorry, let me say that again. I'm only telling you what the source is you're reading and how to generate, what version of bytecode to generate. I'm not telling you what version you're building against. Because you don't know that, I might try to use some calls that don't make sense. So this is definitely not what we actually want to do. This is much closer to what we really want to do here, because we're going to say, here's the list of all the other stuff that makes sense. But the thing is, we know what other class path we're going to build against. We have a special class path. This isn't quite right. This is close enough, though, I think. We think that's close enough. What we really want is a J-linked image to say, no, for real, this is it. So system just has to point at, man, how long did it take us to find that? Jeez. At an unpacked Java toolchain, like Jackal already produces. Okay. Cool. That took way too long. That is embarrassing how long that took. We don't want system none. We will accept the errors that come out of that. We definitely don't want release 11. Because release 11, I'm pretty sure, let's verify this real quick. Release 11 is going to say which system we're going to use. And if we say this, oh, it doesn't hate that. Well, this is embarrassing. This is super embarrassing. This could have worked all along. We should document what these are for, why we're not... Okay, good. There's something that's real unhappy. Hello world single blew up. I was going to say, this is way too simple. It should not be this easy. Annotations is declaring the unnamed module, but base does not read it. Okay, so we saw this. We saw this mentioned in their own build wiring. Hello world. We're patching base. Oh, but we're not building into base. Is that going to be a problem? Package is not visible. We saw this somewhere. We need to say, let me do what I want when I am doing this. Something in here had a note about JS interop annotations. Allow reads. Add reads, not allow reads. We should comment each of these to explain what's going on here and what they do. Still failed. Allow Jerry classes are allowed to depend on the JS interop annotations. Oh, you have to actually specify the... I'm really dumb. This is a two-part argument. I'm going to accept really dumb. It may seem like I'm doing things that are unusual, but they're not smart things. I'm going to totally accept really dumb here. So this should, if I'm understanding correctly, which maybe it would have made more sense to just dig in and, learn what these tools all do the hard way. But if I understand it correctly, this is saying, I'm going to rewrite your code, and I can use anything else I want. And as long as nobody else tries to pass in something that has a... right. Having read edges is not allowed with release. Okay, so now here's where if we remove that, we're back to source and target. Add all. Source. I'm going to hard code this for the time being. Except not like that. We're going to put it in here. So, with a comma, I forgot what I was saying before. Something about how... It doesn't matter. It really doesn't matter. Come on, baby. It's not failing instantly. It's optimizing JavaScript. I think we got it, guys. This is the slow part, of course. Well, that is super embarrassing at how simple that is. Oh. This should be configurable. Oh no, it failed. Oh, it's a header failure. Who cares? Allow to do this. Set should be. Yeah, how do we phrase this? The specific like code generation features that would require new all right, cool. It's mad at this, by the way, for not having a license header. We just introduced license headers to make sure that they get formatted nicely. Okay, so we should probably make something slightly more complex than this. I'm curious what happens if we make source and target into 8. Does it say, oh, well, now you can't use patch module? So in other words, could we allow this to be, oops, this is the wrong thing. I need source and target. I need this one. What happens if yeah, okay. So there is some risk to saying, can this be configurable? I'm gonna rebalance this. I don't actually need. Go. Bootstrap class path. I don't think we need this anymore either. In fact, I'm not even sure you're allowed to pass it anymore. I'm confused as to how it's letting us get away with that. We still have that warning. System modules path not set. Do we care? is the real question. What happens if we remove this? Does it still work? I understand the license check is going to fail. Sure looks like it's working, though. Damn, guys. You know how long I've been figuring this out, and I just had the wrong pair of args? It's not system none that matters. It's patch module and add reads. I am sure I tried this, though. I mean, obviously I didn't, because it would have worked. Okay, so let's start with that. Let's kill off this. Not believe it, this works. Dimitri, I hope you're watching. We got this. We're going to kill this to say formally murdering the option of running Java 8. Java bytecode has to come from here. We'll just go ahead and snipe that real quick. Interesting that that one was grabbed, but the other one wasn't. Whatever, it doesn't matter. And then I think it's time for this to go away. I think I've actually already got a stash that does this. Let's take a look. It's not that. It is this one. The ijar needs to go away, and Java C test needs to go. Okay, so let's undo this and just stash, pop that stash. There we go. So Java C and ijar are gone now. Irvine doesn't extend from Java C, instead it's its own creature, and drops Java 8, and then this will be a separate patch for adding that. Oops. Guess I clicked. I don't know how I did that. Oops, that's not a draft. Sorry, other screen. Just making the pull request that we just did, and then making the real one for today. We need more testing on this before we're ready for that. So let's make what's a good example? Let's make a Java 11 project. So this is going to be a pain, like it always is. And so we're going to put a simple little POM in here. Nope, not like that. That simple. No, not really. And then we'll say a new transitive dependency for emulation, just to make sure. And then we'll make a new app. I'm just going to go yell at Dimitri just so that he knows this is coming, because I'm really excited about this. This worked. All right, so now we got to populate these. We got to build some quick code in here. I'm going to grab this end of file exception here as our sample. Let's take apart this one here as a really quick. Well, that's not right. There we go. Except now we got emule, and we're going to rename it. I wish I could type. What time is it? I got some time. Let's call it this. And then we're going to put in the emule project, we're going to grab one of these little lib ones, which are pretty simple. And then this artifact ID is emule, which we're going to stick some source main Java IO in. Put this in there instead. And then we're going to need to get it a license header eventually. But let's finish the other stuff first, and we'll put the license headers in. So this is going to have a hard time compiling out of the box. We don't actually even need this dependency here. It might be a good idea to put dependencies on it, though. Annotations on it, just to make sure that we're actually using junk like that. So we'll just make it a JS type, just to mess with it. So we'll make that a JS type, and we'll make this one a JS ignore. That way it's got a proper constructor and not much else. It can have all the usual stuff, and we'll do some import JS interop annotations star. Application now needs a workable POM. Steal this one to start with. You maybe can see the pattern now. I just steal the existing ones and say, okay, here's an app. It's going to be a zip or whatever. It's going to depend. All the names are based on the directory because we just need a quick template for that. Emule. There is no compiler. There is no JRE. Only emule. We're going to run our build. I guess we're going to war it for whatever reason. Let's make a real quick source main Java example app Java package example public class app public void go row new EOF exception. And I'm just going to stitch this up to some simple bit of native code that we'll call it. Let's make this a JS type. Annotations is plural. I think I got that wrong in the other file. Let's go check it. Yep, I got it right. Okay, cool. Is this enough to start trying to build it? See if it works. Looks okay. I would like to make sure to specify, I guess, Java 11. I'm curious if this is going to work. This one here might need some chicanery to get it to actually build. So let's check out our integration test. This is called Java 11 project and emule. Dimitri's not on right now, so he's not one of the 5 AUs. Well, hello. I'm in the Mozilla WebAssembly matrix room, and they now have a new draft for this interface. Cool. Someone seems excited about that, so we want to get on that. Okay, so this is almost certainly failing because you're not allowed to do what I just did. It is source 5 is no longer supported. Right, you need to actually specify I want a relatively modern version of Java. Do these not specify it? Seriously? I don't want to do this. This is silly. We should probably just go ahead and update all of those. Okay, was that right there? Is 1.8, but why did it get stuck on an old version? There we go. That's what we want. We're just going to jack that up to 11. It goes a little beyond 11 at this point. Sorry, bad joke. Where did I put that properties tag? Here it is. Because the whole point of this is, can I do 11 junk? And I guess we should actually put some Java 11 junk in there. So, like, I don't know, what can you do in Java 11? Var string equals s plus hello? Or maybe we, so we're going to make sure the emulation can do var junk, and then we're also going to make sure that the app itself can do exception ex equals, except we don't want exception, we want var row ex. I'm going to run it again. I know it's going to fail pretty quickly for the same reason. I just want to make sure that we're actually exercising all the points here so that if we do something stupid, we will get nailed on it sooner than later. Go. Your problem is cannot find symbol var. Is this not how you use var? Am I dumb? I'm dumb, aren't I? Get rid of some of these. Oops. What dumb thing am I doing? Somebody see it? Is 11 not inherited? Is that the problem? Do I need to actually put it in a... It should have errored out with a, hey, you can't do Java 8 here. Can I find symbol class there? It sure looks like it's not using the right compiler. Yeah, it is using the right one. It's just doing it wrong. What am I doing wrong? Cannot find symbol class var. That's not helpful. So it is just a I don't have Java 11 running problem, but I do have Java 11 running. In fact, I've got 21 running because I jacked it up to make sure I wouldn't break it. Oh, well, okay, so this is, first of all, wrong. That's definitely wrong. And second of all, well, that's really it. Let's go ahead and stick this in a plain Java file and see if we can see what dumbness we have done. I mean, okay, of course you need an import. Great. I recognize that's redundant, but it doesn't make it wrong. Okay, it's possible that it's just you forgot to declare it as a throws, and it's just breaking some other thing along the way, and I didn't read the message properly. Let's hope that's it. That's not it. What Java 11 language features do we have? What else do we have? We got like private methods in interfaces, which is kind of a lame feature. .13.9. Yeah, that's where it is. So now it should be a different error. Cannot find symbol IO exception in example app. Oh, because I didn't import it, because I'm really dumb. So technically I had it marked as throw, and then this is extending. So we're going to say IO is actually after EOF. Okay, that's way further than I expected to get here. EOF can be an constructor if and only if all the other constructors in the class delegate to it, right? You need explicit. Yeah. Okay, fine. We will just do this. It's silly, but whatever. I'm going to make a note here that this is silly for the sake of being silly. New failure. I see. I'm still expecting this to fail as part of compiling into Java 11, because this, as bytecode in Java 11, should set off warning flags to say, no, you can't do that. And now we have failure in app because there's no WebXML. It's a pretty shit reason to fail, but I guess fine. Sure, we'll add one, I guess. Let's do source main. I'm missing something here. I'm missing something. So Dimitri's going to catch me out. I'm not even going to bother tagging this as anything but a draft pull request, because we should not be able to build to Java 11 with this. Success. Yep. So the integration test succeeded. It's just the formatter that failed. So we need to run the Maven formatter format, or whatever. License? Format license? License format? I'm going to run the other integration tests real quick. The what do you call them? The archetypes. Make sure they sanity check. Failure. Okay. This is a race condition, I think, or is it indicative of an earlier error? Annotation processors didn't work. Annotation processing is enabled because one or more processors were found on the class path. Yep, I don't care about your system modules not checked. Okay. A future release of Java-C may disable annotation processing, which will make me very sad, when at least one processor is specified by name, none are, or a search path is specified, none are, or annotation, but we don't set any though. Use proc none to disable. We aren't. And then we get an error, cannot find symbol, test app test. Cannot find symbol test app. So this is just our plain bytecode build. Which is supposed to run annotation processors. And for some reason isn't building. Let's see here. Where is our Archetypes. Which one is this? Is this a simple archetype? Probably. Simple. So this is ostensibly valid code. And then our test depends on example test app, right? Oh, but not with an import. So when that fails, the test summary file never gets generated, and so we don't have the ability to figure out which tests we need to run. So first it tried to run bytecode on the app itself, and then it said, okay, now let's run on the test. Let's look in the cache here, see if we generated output for what's going on there. Nope, just the same thing again. Well, there's a test summary. Didn't it just say it couldn't do that? Is this just a race? That would be dumb. Error reading test summary. Target test app snapshot test. It's a failure, but we generated the file. The annotation processor ran, but we did not get the... Yeah, it didn't actually copy the stuff out. The test processor also should have run. Oh no, it doesn't run that normally. Okay, that's fine, I guess. And the complaint here is I can't find test app. Does it not have a dependency on its own test code? Here's our cache summary, which should say, in order to build you, I need JS interrupt base, don't care about you, test app itself, and I need test app.java. So it should be on the class path. how my debug logging is set up, if this is going to automatically dump to the output log, but not to the message from Frank. Sorry, I missed this. Pretty cool watching you dig around. Would love to see schedules a bit earlier. Yeah, I'm sorry, man. I can't get on much earlier. Would love to see a session where you implement something in GWT to get an idea how to do that. Yeah, Frank, if you catch this later, I'd love to get up a little earlier. The stream metrics we get all say I should get up later, get started later. So I don't know. I just do what I can. I get online when I can. They're always available on YouTube. We got tons of these on YouTube. All right, it failed. Let's see if we got some good logs this time. Bytecode. Yeah, it does log all these. Nice. Okay, so here's the compiler flags, and here's the class path. So with a little more care, we should be able to actually make these easy for us to traverse. And build our own JUnit, 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 JS interrupt base, annotations, JRE, and then here's the code for the oops, that's not right. So there's test app and results, like it should be. So if we build our own javac command, let's go into archetypes, simple target, test, project, test app, project, test app. Is this where I need to be? Yeah. So javac, we're going to pass in, let's just skip ahead and do the interesting stuff. Source 11, target 11, patch module, java.base equals dot, add reads java base equals all unnamed. Let's skip the rest, it'll be fine. Oops, that's not what I meant. We need to grab all of these paths technically, but I might get bored. So let's just grab the ones we really need. This, JS interrupt, annotations. Oh, we need to do test code. Yeah, so I guess I do need a bunch of them. Okay, that's fine. It's possible we want to be a little more careful about this, I guess, then. Okay, so that will get us our own bytecode and JS interrupt base. I don't actually need JS interrupt base. I need JS interrupt annotations. Promise, core, JRE. Okay, I guess we need the JRE, right? Definitely need annotations. Here it is. And then let's just grab the source itself. So source test Java. And then we need the out directory. I forgot about that. That's -D, right? Okay, so it doesn't like the absence of the annotation. Let's grab the JUnit annotation, because that's definitely a problem. It doesn't like the absence of the JUnit itself. JUnit annotations, where's our actual JUnit? Emule, here it is. So now we're down to the weird stuff. Test app cannot find symbol. The very first item in the class path I put here should contain that. It's a really long path, to be fair. So this should just have a, ooh, why did you auto, there we go. Yep, I got it right. It's got the com in it. Did the import get squirreled up? Oh, I don't have an import. I don't have an import. Is it because there's some cross-module funkiness around, hey, can you import things like that? Ooh, that would suck so much if we had to break that. So what if we change the test, have an import in its own package? Like that. Does that fix it? It does not. It actually complains. Line 6 cannot find symbol, com, example, test app. Example, test app. Test app.class and test app.java. Example test app. It has a constant public string hello world. It has non-module load. It has a method. It has a constructor. This is disassembling the bytecode real quick and just say, hey, what's in here? And we can use this for all kinds of stuff. We did this a bunch last week, 2 weeks ago. We can say actually dump out the bytecode for all this junk in here and make sure it's all real. And it seems to be. So it seems to be a good class path. Why can't it read it? Cannot find symbol. Example test app. Do we have a verbose flag we can pass? Yeah, just straight up verbose. I'm going to get lunch soon, and then I'm going to give up on this for a little while, and then we'll come back and we'll get this hammered out. This is going to be something dumb. Hopefully it's something dumb. So I wonder if we need a special system image to get it over whatever this is going to be. We're loading our own file test. We grab the module info. We search for source files, including in test app's own contents. Jackal, so it found this class file, but it can't find that one. Let's get the full log here with nothing else. What did I do wrong? Let's move the class path ordering just in case somebody really cares about this. Let's just go through this real quick to make sure this contains what we think it does. Example test app. Example test app. So same package crossing between 2 different compiles. It's really grumpy about that. And it wants to get this constant, and it wants to get the constructor, and it wants to get the import. So it's 3 different. Let's see, it's got to grab a bunch of stuff to get to this point. One of our compiler flags here, our otherwise magical compiler flags, is doing this to us. So what if we stick the system back in again? Oops, I need a space there. No, that's not it. It might at least suppress our other warning that we were getting about, hey, you don't have a system, you jerk. Although I don't actually see that warning going off right now. If we get rid of our other args, just to make sure that what we're doing wrong here is something to do with them. I want to keep my source and my target. I want to stop patching the module, and I want to stop adding the reads. Invalid flag. I forgot to, yeah, I deleted the -d. Oh, interesting. DOM global is necessary for test app. It is trying to compile things that are already compiled. We need a implicit none. You shouldn't need a transitive dependency for this. Why are you trying to compile test app? Implicit none should mean don't go ahead and transitively compile my dependencies. But that appears to be what it's doing. Just for the moment, it's wrong, but I'm just going to add some more here. I mean, technically, it should have been on there anyway, so I guess I can add elemental. But once I go down that path, I'm also going to need promise too. Elemental DOM, just DOM, right? Yeah. Oops. B. And then we need promise, of course, because now we're transitively compiling everything, which is totally wrong, and implicit none should stop that, but it isn't. So something else is funny right now, but whatever. And then from promise, we need core. Or, sorry, other way around. From DOM, we need core. Oh, where's core? Here it is. And then we need internal annotations, like do not autobox. Okay, so that worked. Something about one of our other flags is making it irritated. Let's do this. This. Let's get rid of the prop none. Let's look real quick just to make sure that we are getting just the one class we expect. Good. So it must just be walking them anyway, even though it doesn't compile them. Whatever. And then we should need, for some packages, but not all of them, I don't think this is going to work without a module. It does. And then it's our patch module that breaks it. Spelling is key. Yeah. Our patch module breaks it. Probably because none of the other stuff we're doing is in a module. You're only supposed to patch module when you're going to modify a module. That's my guess. Okay, so this is an open problem still. We're not quite there. We need to figure out either if we sometimes change the module or if we just build a new module as we go and keep appending junk to it and say, well, this is part of the module and this is part of the module and this is part of the module. Or something like that to allow us to be able to add more stuff. At this time, however, I'm going to go get some lunch. We've gotten really close here. This is the closest we've gotten before. And it seems like it all makes sense. I mean, this part even seems like it sort of makes sense. We should be able to read other modules, though. Allow any user code. So add reads should allow our stuff newly in Java base to read other modules, which is how we were able to do imports on the JS interop annotations to begin with. Without adding this, we couldn't even reference JS interop. So why is it not working now to let us reference other already compiled stuff? Is it because there's sources in there too or something? That would be super irritating if we had to filter all that stuff out. I mean, not the end of the world, but super irritating. Okay, I'm going to go ahead and call it then for today. Thanks for hanging out, everybody. Did not get to any other stuff we wanted to, but we did do a little bit of cleanup. And then the next piece is going to be getting this ready. So it's a nice small patch. We got a test for it. The test passes. It would be nice to better understand what's happening here. Maybe just adding a test would be enough to know what's going on there. That might be a good first step for this afternoon. And then I'm getting back to GWT and trying to figure out why the GDT update broke. Console log of all things, and it has to do with varargs and JS interop. So if I get the chance, I'll stream that this afternoon, but I don't know how likely that is. So thanks for hanging out, and hopefully we'll see you next week. If I can find the end button. This is always the problem. Don't get ready to say you're done until you can find the button.